This section's about solving polynomial equations. We've already done essentially that with the factoring anyway, because once you've found a factor, what the fundamental theorem tells us is, or fundamental factor theorem tells us, is that a factor is equal to a solution when we set that factor equal to 0. So the roots, they're often called roots or zeros of pz, okay, for our polynomial z, are these parts here, these answers. So for example, here you'd set z minus a1 for the first one, alpha 1, equals 0, which would imply that z equals alpha 1 is a solution. So that's the idea between the link between factors and solutions. Now we also have the formula for quadratics that we had for quadratics in x. It is completely applicable for z, but the cool thing is previously when you had a negative underneath the square root you couldn't continue. But now when you have a negative under the square root you can continue by remembering that key result, which is that I squared equals negative 1. We're going to use that to help us get out of trouble basically when you've got a negative under the square root. So if we look at the first one here, we've got, or example 19, got z squared equals 2z minus 5. First thing you need to do is put your quadratic equation in this form, okay, which is the form where you've got an a, a b and a c, and they will go into our quadratic formula. So we're going to just rearrange this, z squared minus 2z plus 5. I've just moved everything over to that side, equals 0. Now, it's a good idea to write down what a is and b is. So a is 1, b is negative 2, that's what's in front of z, and c is 5. Just because then when you're using your quadratic formula, you can put everything in very easily. You can see negative b is the first thing that we have to do, and I'm actually going to write the whole quadratic formula out just so it's above my working. Now when you put negative b in, you can see b is a negative 2, so this would be plus 2, positive 2. b squared is 4 minus 4 times a, which is 1, times c, which is 5. Let's expand that over. And 2 times a is 1, so that's going to be 2 underneath. So we've got 2 plus or minus. Inside here we're going to have 4 minus 20, okay, which is equal to 2 plus or minus. Now 4 minus 20 is minus 16. Now this is where normally when you were doing your solutions for quadratics you'd be stuck because you can't continue from here. But we can now manufacture, I know in other work examples we manufactured a minus so we could complete the square. This time what we want to do is we want to make this a plus. And what we're going to do that is we're going to multiply this negative 16 by I squared, because we know that I squared is equal to negative 1. So what you've done here, do that again, that was a bit strange, is we've got a negative 1 here, so this is negative 16, so that's what we had before, and that's over 2. Now what I'm going to do, I've got 2 plus or minus. We can actually do the square root of this now, because remember one of those key rules with surds, and I always show these over and over again just so it just stays in your head, so you get used to the fact that square root of two things multiplied is the square root of each of those things that have been multiplied. So square root of 16 is 4, square root of I squared is I. So that means that we've got two solutions here. Divide the top by 2, 1 plus or minus 2i. So that means that our solutions, and you should always finish off, if you're asked a question where it's asking solve, make sure you answer it with solutions are z equals 1 plus or minus 2i. So these are the solutions as opposed to the factors of an equation. Now we can also use the CAS to solve this. So if we look at this equation here, z squared equals 2z minus 5. I'm going to get the CAS up. Just move this over a bit so you can see. And I'll just delete these. So if we get up our CAS, we go into menu, go into algebra, and then complex. So C for complex, and solve. We can actually put, so C solve is the complex solution, solution algorithm. So if we type in our equation, you don't even have to rearrange this. You can put it in the way it is in the book, which is like this. Make sure you say you're solving for Z, so comma Z, and press enter. And you can see we've got our answers there, 1 plus or minus 2i. And if we have a look back, yep, 1 plus or minus 2i. So you can use your CAS to solve these as well, or even just as a great check to see if your answers are correct.